in my room right now. I don't know when I'm gonna get rid of them. I got like 4, like next to me, just like 4 empty water bottles. I don't even know. But yeah, my voice has gotten better, meaning I don't sound as raspy as I did before. So I think it's a good idea to definitely live stream. And I missed a day, okay? About 2 weeks ago on a Tuesday, I didn't even go to school in the morning. And wanna know what that meant? I missed science. So I'm gonna do my science right now. Okay. Everything we do, feel, or think is the result of what basic units of brain structure? I guess I gotta watch the video. Hold up. I got a notification. What is this? V-Bucks. V-Bucks are trash.
Most interesting cell in the human body is, but I think easily the neuron would make the top 5. And if not just because the cell itself is interesting, the fact that it essentially makes up our brain and our nervous system and is responsible for the thoughts and our feelings and maybe.
So I'm gonna assume the first answer is neurons. Actually, I should probably have my answer in a different font. Here we go, Helvetica. And not italic. And fully black. Actually, I'll just have it like that. I think these were meant to be printed out. I actually don't know. How many neurons?
For all of our ascensions, I think would easily make it the top 1 or 2 cells. So what I want to do is first just show you what a neuron looks like. And of course, this is kind of the perfect example. This isn't what all neurons look like. And then we're going to talk.
Hold up, this is on Khan Academy. That's pretty epic. What do the comments say? Are you sure it isn't just your neurons telling you that they're the coolest cell? Let me pick a better color. Continues to use the exact same shade of yellow. Wait.
Talk a little bit about how it performs its function, which is essentially communication, essentially transmitting signals across its length depending on the signals it receives. So if I were to draw a neuron, let me pick a better color. So I'm going to make my brush size a little bit thinner. So let's say I have a neuron. It looks something like this. So in the middle you have your...
Hold up. Yeah, it's a little bit thinner.
Soma, and then from the soma, so let me draw the nucleus. Draw my
nucleus.
So this is a nucleus,
yes.
Just like any cell's nucleus. And then
how do I know that's not a testicle?
The body of the neuron, and then the neuron has these little things sticking out from it that keep branching off. I swear, I keep hearing a door opening and closing outside. I don't want to spend too much time just drawing the neuron, but you probably
spend as much time as you need. I got all day.
Before. And these branches off of the soma of the neuron, off of its body, these are called dendrites.
Dendrites. You know you can edit these things out, right, buddy? Right? You know that? Or are you too lazy to edit these out?
Right, so they can keep splitting off like that. I'm going to do a fairly reasonable drawing, so I'll spend a little time doing that. The one last dendrite, just like that. So these right here, these are dendrites. And these tend to be, and nothing is always the case in biology, sometimes different parts of different cells perform other functions, but these tend to be where the neuron receives its signal. And we'll talk more about what it means to receive and transmit a signal in this video and probably in the next few. So this is where it receives.
Oh, you made multiple videos on this.
And then, so this is.
But with so many synapses on my dendrites, which ones do I listen to?
This is the dendrite. This right here is the soma. Soma means body. This is the body of the neuron.
I didn't know that.
And then we have kind of a, you can almost view it as a tail of the neuron. It's called the axon. The axon.
Axon, team axon.
A neuron could be, a reasonably normal sized cell, although there is a huge range. But the axons can be quite long. They could be short, sometimes in the brain.
They can be quite long. They can also be short. That kind of reminds me of something else. I think it starts with a P.
You might have very small axons, but you might have axons that go down the spinal column or that go along one of your limbs, or if we're talking about a dinosaur, go along one of a dinosaur's limbs. So the axon can actually stretch several feet. Not all neurons' axons are several feet, but they could be. And this is really where a lot of the distance of the signal gets traveled. So let me draw the axon. So the axon will look something like this. And at the end, it ends at the axon terminal, where it can connect to other dendrites or maybe to other types of tissue or muscle if the point of this neuron is to tell a muscle to do something. So at the end of the axon, you have the axon terminal right there. Do my best to draw it. It's like that. Let me label it. So this is the axon. This is the axon terminal. Terminal. And you'll sometimes hear the word, the point at which the soma, or the body of the neuron, connects to the axon is often referred to as the axon hillock. Or maybe you can kind of view it as kind of a lump. It starts to form the axon.
Well, unfortunately for you, buddy, I did not bring my notebook with me. It's kind of my fault.
So it's the axon hillock. And then we're going to talk about, I think there's a C there. We're going to talk about how the impulses travel, and a huge part in what allows them to travel efficiently are these...
Efficiently. Dude, like I said before, you can edit these mistakes out.
Insulating cells around the axon. These insulating cells around the axon. We're going to talk about this in detail and how they actually work, but it's good just to have the anatomical structure first. So these are called Schwann cells. Schwann cells, and they make up the myelin sheath. So this covering, this insulation at different intervals around the axon, this is called the myelin sheath. So Schwann cells make up the myelin sheath. I'll do one more just like that. So I'll say Schwann cells or myelin sheath. And then these little spaces between the myelin sheath, just so we have all of the terminology from, so we know the entire anatomy of the neuron. These are called the nodes of Ranvier. Nodes of Ranvier. I guess they're named after Ranvier. Maybe
I think he spelled some...
These little slots here where you...
What the heck kind of... Oh, that's cursive. Crap.
Don't have myelin sheaths, so these are the nodes.
You see, I didn't realize that was cursive. Wait, no, it's not cursive. It's connected to this. I don't freaking know. Anyways, that looks like an upside down N, if I'm being honest.
Nodes of Ranvier. So the general idea, as I mentioned, is that you get a signal here, and we're going to talk more about what the signal means. And then that signal gets actually the signals can be summed, so you might have one little signal right there, another signal right there, and then you'll have maybe a larger signal there and there. And that the combined effects of these signals get summed up, and they travel to the hillock, and if they're large enough, they're going to trigger an action potential on the axon, which will cause a signal to travel down the balance of the axon. And then over here, it might be connected via synapses to other dendrites or muscles. And we'll talk more about synapses, and those might help trigger other things. And so you're saying, well, what's triggering these things here? Well, this could be the terminal end of other neurons' axes.
So I feel like this is not the right video for this specific sheet. How are neurons contained in the human... No, how many? I don't know if he actually said that.
Spend a little time doing that. The one last dendrite, just like that. So these right here, these are dendrites. And these tend to be, and nothing is always the case in biology, sometimes different parts of different cells perform other functions, but these tend to be where the neuron receives its signal. And we'll talk more about what it means to receive and transmit a signal in this video and probably the next few. So this is where it receives the signal. And then, so this is the dendrite. This right here is the soma. Soma means body. This is the body of the neuron.
All right.
And then we're going to talk a little bit about how it performs its function, which is essentially communication, essentially transmitting signals across its length, depending on the signals it receives. So if I were to draw a neuron, let me pick a better color. So let me draw my brush size a little bit thinner. So let's say I have a neuron. It looks something like this. So in the middle you have your soma, and then from the soma, so let me draw the nucleus. Try my best. This is a nucleus, just like any cell's nucleus. And then the soma is considered the body of the neuron. And then the neuron has these little things sticking out from it that keep branching off. Maybe they look something like this. I don't want to spend too much time just drawing the neuron, but you've probably seen drawings like this before. And these branches off of the soma of the neuron, off of its body, these are called dendrites. And they can keep splitting off like that. I want to do a fairly reasonable drawing, so I'll spend a little time doing that. One last dendrite, just like that. So these right here, these are dendrites. And these tend to be, and nothing is always the case in biology, sometimes different parts of different cells perform other functions, but these tend to be where the neuron receives its signal. And we'll talk more about what it means to receive and transmit a signal in this video and probably in the next view. So this is where it receives the signal. And then, so this is the dendrite. This right here is the soma. Soma means body. This is the body of the neuron. And then we have kind of you can almost use a tail of the neuron. It's called the axon. The axon.
Yeah, I don't feel like he gives me that answer. Neuron video. Well, this is anatomy of the neuron. Yeah, I don't think I'm gonna find my answer. I would go back to the place where I found this video, but I feel like I might accidentally dox someone, so I think it's best to just end the stream here.